Good evening and thank you so much for joining us on this episode of Your Health. My name is Purity Museo. In October last year, the World Health Organization WHO recommended widespread use of RTS S Malaria vaccine among children in sub-Saharan Africa and in other regions with moderate to high falciparum malaria transmission. The recommendation is based on results from an ongoing pilot program in Ghana, Kenya and Malawi that has reached more than 800,000 children since 2019. Kenya, in partnership with WHO, rolled out the world's first malaria vaccine in a landmark phased introduction program in September 2019, taking place in 8 counties, namely Homa Bay, Kisumu, Migori, Siaya, Busia, Bungoma, Vihiga and Kakamega counties. Nambale is one of the sub-counties in Busia that was identified to take part in the pilot program owing to the huge burden of malaria disease. And this week on Your Health, we take you to Nambale and share with you a journey that has seen hundreds of lives of children in the area saved courtesy of the 4-dose jab. Have a look. According to the World Health Organization, WHO, malaria is a life-threatening disease caused by parasites that are transmitted to people through the bites of infected female Anopheles mosquitoes. In 2020, there were an estimated 241 million cases of malaria worldwide. The WHO African region carries a disproportionately high share of the global malaria burden. In 2020, the region was home to 95% of malaria cases and 96% of malaria deaths. The first symptoms include fever, headache, and chills. The WHO Global Technical Strategy for Malaria 2016 to 2030 sets ambitious global targets, including reducing malaria case incidence by at least 90% by 2030, reducing malaria mortality rates by at least 90% by 2030, eliminating malaria in at least 35 countries by 2030, preventing a resurgence of malaria in all countries that are malaria-free. Since October 2021, WHO recommended broad use of the RTS S Malaria vaccine among children living in regions with moderate to high falciparum malaria transmission. The vaccine has been shown to significantly reduce malaria and deadly severe malaria among young children. In September 2019, Kenya, in partnership with the World Health Organization, rolled out the first malaria vaccine in a landmark phased introduction program in 8 endemic counties, including Homa Bay, Kisumu, Migori, Siaya, Busia, Bungoma, Vihiga and Kakamega counties. In Nambale Sub-County, Busia County, the vaccination program among children began as soon as Kenya rolled out the program in 2019.
Malaria has been a great burden in this part of the country, and it's one of the diseases that has led to deaths of under 5s, mostly pregnant women, because they are the group that is mostly affected by the seriousness of the disease.
Normally when the mother comes, this is the waiting bay. They wait here and we take the weight of the child. After taking the weight of the child, we do take the height. We go through the MCH book. In the book, we check the age of the child, because the malaria vaccine, the first dose, it's given at 6 months.
We store our vaccines between positive 8 and positive 2 and positive 8. So I document the whole month. Yeah, and for each target is able to keep the records of the temperatures for a whole month. So even if somebody comes in, he's able to read. And also it is monitored from Nairobi using this gadget here.
Priscilla Aroni is here to have her baby get a 3rd malaria vaccine dose.
Leo nilikuwa nimeleta mtoto chanjo ya mwezi 9. Anaitwa Gift Atiang, ako na 9 months. Tangu apate ya mwezi 6, sijaona malaria yoyote.
The first dose is given at 6 months, and then the second dose is given at 7 months, the third dose is given at 9 months, and then the 4th dose is given at 2 years. And we find that at 9 months, according to the immunization schedule, we have measles vaccine, which is given to the same child at 9 months. So during 9 months, we give measles on the right hand and then the malaria vaccine on the left hand, so that there's no interaction, the reactions of the vaccine. I'm offering malaria, the 3rd dose.
Today?
Yes, today. But normally in the days, during the day, we offer all the immunization, all the vaccines. All the vaccines we offer every day, from Monday to Friday. We are using every content that is inside. We are using all of it.
How much is it?
It's 1 meal.
So the unit is 1 meal, the vaccine is 1 meal?
Yes. Pole baby, pole, pole, pole mama, pole.
Nambale Sub-County Hospital serves as the main vaccination center for this area.
Mara kwanza alipata malaria vaccine akiwa around 6, bila alifikisha 6 months. Then wakanipea mwezi mmoja kurudi. Tukarudi akapewa dozi ya pili akiwa 7 months. Alafu dozi ya 3 akapewa akiwa 9 months. Alafu ameendelea hivyo bila alifika 2 years. Akapewa sasa the 4th dose ya malaria. Tangu ni mzee hajaipata malaria, sitakudanganya. Hajawahi pata malaria. Patanga tu hizi homa, maybe infection, but malaria hajawahi pata.
According to the Minister of Health, as at 30th of November 2021, a total of 671,762 malaria vaccine doses had been administered.
Huyu mtoto vile nilimzaa ako tofauti na wale watoto wenye nimezaanga nyuma. Tofauti yenye iko, huyu mtoto amepata hizo chanjo, imemsaidia sababu malaria sio sana apate. Wenye wajaleta watoto hao, naweza kuwashauri kuleta watoto kwa chanjo ili wapate chanjo. Na watazongesha ugonjwa wa malaria kuwe kando.
Over the last 2 decades, expanded access to WHO-recommended malaria prevention tools and strategies, including effective vector control and use of preventive anti-malarial drugs, has had a major impact in reducing the global burden of this disease. However, insecticide resistance has emerged as one of the major challenges facing national malaria control programs in Africa.
To become resistant means that's there is exposure of the same chemical over time. So because Busi is known for tobacco and any other agricultural, so they're using pesticides, and most of these pesticides have pyrethroids in it, and our nets have pyrethroids in it. So this mosquito has been exposed to the same class of insecticides for a very long time.
It's time they change the tact.
Yes, they have to change the tact.
At the Kisumu Entomology Laboratory at the Cambridge Center, James Opala and his team perform a range of molecular analysis on mosquito populations, from assaying resistance to understanding the species composition of different mosquito populations.
If we rear them here, we are able to go do research on different insecticides by just exposing them to different concentration of this insecticide, so that we can know the resistance or the susceptibility of the mosquitoes, so that if an insecticide, if a mosquito, a certain species of a mosquito is resistant to a certain insecticide, then the insecticide, if approved by the WHO, can actually be distributed to the communities for purposes of containing malaria transmission. The research on mosquito rearing has actually proved to some extent that malaria can be contained in a way that after we have reared and gotten the adult mosquito, we expose them to these. We have different biases being done, and the biases are actually, we are able to get the results from the biases based on the numbers that are resistant and the number that are susceptible. So if we find that the deltamethrin is of a different of 0.5 concentration, was the mosquitoes from Sierra were resistant to the 0.5. Now what we do is just to increase the concentration and again expose these mosquitoes to a different concentration from 0.5 maybe to 1. Now we test that the 0.5 they were resistant and 0 and 1 they are now susceptible.
The study is done on both reared and wild mosquitoes.
For a mosquito adult female, it has, we know that mosquitoes has proboscis. So it is the proboscis that we use to distinguish a male and a female. Mosquitoes will start developing immediately you introduce an egg. You dispense an egg to water. Mosquitoes will start developing to larvae. Yeah, so that's where we get the larvae. After getting the larvae, they develop to pupae, then to adults.
They are fed using a process called artificial membrane feeding.
It is connected to the electricity and it depicts human body temperature. It has we have a membrane that we screw and then provide the female mosquitoes the blood from a slaughterhouse. We get blood from slaughterhouse, we screw in those machine, then we give them. That's the same way. The days are the same, 2 days. Then we introduce a laying pad, we dispense in water. After dispensing in water, they start to develop to larvae, adult, larvae, pupae, then adult. So the procedure is a cycle. We get the adults, we feed the adults, then get eggs. That's why we say the mosquitoes undergoes complete metamorphosis. For the larval, they are put in a condition of a temperature of 30 plus or negative 2 and a humidity of 80 plus or negative 10. When we want to introduce the laying pad, we just wet this filter paper. After wetting this filter paper, you wet a cotton wool and place the filter paper inside the petri dish. Then the mosquito will be bubbling and moving around over the. If you introduce this inside the cage, mosquito will feel like it's wet, and as they move around, they lay their eggs. After getting the eggs, then we dispense it in a tray. They take 24 hours to develop to larvae, but larvae now grows in instars. We have first instar, second, third, and fourth. And the first instar is smaller than the fourth. They grow each day.
Inside here.
Yes, they will grow when they are here. We have this pipette that we use to pick the pupae. So these ones, I just picked pupae from here today.
So how do you know that it's pupil?
So the pupae are these of this shape.
Oh, okay.
So if you see these ones are lobe shaped, and these if you compare this and larvae, there's a difference. We give them tentatively two times in a day, because and we do a change. If it is 2 times, we change water after every 2 days, because this food will form a scum, and they will not be able to receive oxygen. After 4th day, they change into pupae. So at pupae stage, they don't feed. They only utilize foods that was used during larval stage.
Why don't they feed? Because they're not active?
Well, yeah, they are not active. You see, at this stage, they just want to. These ones will start flying. That's why from here, I just want to place them. So it takes 24 hours only. Yeah. So in the evening, they will start. They will be all adults, these ones. So from here, the larvae are feeding at this stage. And if you want to know that they are they require food, they will settle at the edges of this of the tray. You label a cage with a date, tomorrow's date, because tomorrow they will be day one. You see, our experiments, we run experiments with 3 to 5 days old mosquitoes. So if you have mosquitoes of 1 day, you cannot run an experiment with. And at adult stage, we only provide them with sugar, 10% sugar solution. So this one, 10% after preparing, you dissolve sugar in water, then you dip the cotton wool in that water. So the cotton wool is dissolved in, or the whole of it is dissolved in water, in the sugar solution now.
The wild mosquitoes are harvested from different breeding sites, then taken to the lab for study.
After collection from field, they are being brought in larval form, and the larvae are being provided with the food. Each day we provide them food. If they are being brought in tins, then we distribute them in these trays. Because I talked of population, the number and the sizes. So if you distribute them in different trays, you will be able to produce them high number, because if you mix the L1s and the L2s, the L3s and L4s, they will feed on the smaller ones. Now you mix them based on their sizes, and you must ensure that you label. Like this one is from a different location, and this one is from a different location. That one will enable you not to do a contamination, to have a contamination of different sites.
We are exposing mosquito to different insecticides, because now, as you know, that the malaria incidence actually is increasing. So we want to see why mosquitoes are actually getting resistance. So we want to test the efficacy of these insecticides. So we have different types of insecticides, different classes of insecticides. We have pyrethroids, which is mostly the insecticide used for treating our nets. We have other classes like carbamates, we have organophosphates and organochlorines. So the last three actually we are not using for treating our nets. So the only pyrethroids are used for treating the nets because it's safe for human. This is our test tube, the one that we are using for exposing the mosquitoes, at least to avoid contamination. And actually the insecticide inside here, the name has to be visible at the tube, so that you know which type of insecticide or which class of insecticide you're dealing with. So this is very important, the tube. And you can see the one that this clip, it is copper. Actually the color. It also helps us to know this is a test clip, at least to avoid any contamination. This one is green, dotted is for exposure, not exposure, for holding. And this is silver, just to give us the difference. This also, it's called a gate. And this is called an aspirator. So what we can do, the importance of this, when you're introducing mosquitoes, when you're introducing mosquitoes here, there are some that actually may not be very active. Maybe you can injure them when you are actually introducing them to this cap or the tube. So we'll put here and maybe wait for maybe 1 minute, so that any mosquito that is not actively flying, we'll just remove it, so that when we introduce them to the insecticide treated paper, we are sure that they were all active. From here, I introduce them using this small hole. This for introducing now them. The first, I will introduce them to the holding tube, at least maybe for some few minutes, few seconds, to check if they are all fit. And then from there now, I introduce them to the exposure tube or test tube. So after that, maybe you've checked they are all fit. They are all fit, actually they are all resting on the wall. There is none that is injured, and none that is actually on at the base. So what I'll do, I'll just take the testing tube, I'll attach it here, and then I'll just slide this is called a gate. I slide the gate, and then I just take them this way. With a small, very small force, I should not actually push them because I can injure them, they're so fragile. Just do this. This paper is impregnated with that specific insecticide that you are trying to test. So we can't come and do, this is actually called a WHO tube assay, because I can say we have 3 types of bioassays in this lab. The first type is WHO tube bioassay, that's what I'm doing now. We come and wrap this the way you've seen. We introduce our mosquitoes inside here. Our live mosquitoes active, 3 to 5 days old. And then after that, we monitor. After every 10 minutes, we check. We want to see the knocked down, the one that's actually have been knocked down.
You said it was supposed to be how many minutes?
1 hour, but at an interval of 10 minutes, I'll be checking the knockdown. So even as you can see, the nuclear actually is just increasing as the time increases. Really, when I ensure that all of them are actually here, I'll just take them. Did I actually make sure that all of them are here? Just take them. They are all here now. They are all in the testing tube, and then I just put it this way. And then I start my recording with our stopwatch.
So this tube has the insecticide?
Yes, the insecticide here. That's why I was saying, when you are putting it, I just start for 10 minutes. So when you are actually doing the, preparing your bottles or the tube, you ensure that the insecticide is visible on the wall. So this is the insecticide name. It's called pimethyl. It's a class of insecticide. After 10 minutes, I now check to see the knockdown, and then I monitor for 1 hour, and then after that, I'll take them back the way I did. I just attach it, and then I reintroduce them to this cup or this tube, then give them some sugar solution. Actually, that is the only meal that they are feeding on. For 24 hours, tomorrow exactly the same time, I'll just come and check the mortality. As for now, we cannot say that we can change the insecticide for treating the nets. But we can change the insecticide maybe for spraying the walls, and we can bring some other product that do not have pyrethroids that actually helps to kill mosquitoes before someone goes to the nets.
Purity Museo, your health.